Welcome back to Stewart Science. We talked in the last episode about how to sort energy into its different kinds, and we said that there's a lot more that goes into it than just being kinetic or potential. So today I want to talk about how we calculate and make predictions with one kind of potential energy, and that's gravitational potential energy. And so I'll start by using an example here to help us kind of see where this equation comes from. So if this was a person, let's say she's exercising, and she wanted to work out, what are some things that would make this a harder workout for her to do? Well, one of those things would be how high she tosses the ball. If she throws it higher, it's going to take more effort from her to do that. So height is one thing that plays a role. Another thing that plays a role is how much mass this ball has. If she's tossing a 5-pound ball, it's going to be a lot less difficult than if she's tossing a 10-pound ball. So the heavier it is, the more energy it's going to take from her in order to throw it. So mass and height are two things that affect energy. And the last one, maybe it's one that you wouldn't think of because we're kind of stuck here on this planet, but the last one would be gravity. If she went to a place or a planet that had more gravity, it would take more energy for her to toss the same ball the same height. And so gravity plays a role. Now for us, that gravity is always going to be the same. Everywhere on Earth, gravity is about equal. But let's say that one day comes and we're on a different planet or we're on the moon or some other place where gravity isn't the same, then we'll have to take into account gravity when we're doing a workout. That equation then is U equals mgh. M times g times h. Now, I don't know why they used U. It just stands for gravitational potential energy. So if you want to use G, P, E instead of U, go for it. That's just not what you're going to see in a textbook. So some person somewhere once decided that U is going to represent gravitational potential energy. I don't know why they did, but they did. So M is mass, G is gravity, H is height. So mass times gravity times height gives us our energy. And our energy unit is a joule. Kind of like a Newton is the unit for force, and that Newton means kilogram meter per second squared. Well, a joule is a kilogram meter squared per second squared. Again, don't ask me where this came from. I could explain it, but not at the ninth grade level. Joule, Joule, that's the guy's name. He's a French scientist. He did a lot of work with energy. Kind of like Newton, the guy's name who did a lot with force. We named the unit for force after him. So our unit from now on is going to be joules. Not like jewels in the crown, like Jules, this guy's last name. So let's say I'm giving you an example of this woman's workout. She's tossing a weighted ball in the air, and I want to calculate how many calories is she burning from this workout, just from the toss. And so what I do is I take this information that you see in front of you, and I just need to stick it for the letter that it represents in that equation. So we have U equals mgh. One of these is G, one of these is M, one of these is H or U, and we just find them when we don't know. So we have to think, what is this? G, that goes in for G. I already told you that. 3.2 M, that's 3.2 meters. That's a height. So that goes in for H. And then 5.2 kg, that's a mass, that goes in for M. Now, I know it can get a little bit confusing because the unit for height is meters, and there's an M in the equation. But you have to think, there's a difference between a unit and a variable. A variable is what it represents. A unit is what we measure it in. So like a variable could be height, but I could also measure that in feet or yards. Now I wouldn't because I'm a scientist and I respect myself, but G is 9.8 always. 3.2 meters tells us that it's a height, and then 5 kilograms is a mass. So I'm going to set up this equation, and I'm going to replace all the letters that I know with the numbers that I found out. So So I've got U, still have that, equals M, which I know is 5, times G, which is still 9.8, times H, which is 3.2. And so I just go to my calculator and I type those numbers in and I get an answer. So here I go. And I get 156.8. So U equals 156.8. I just need a unit, and the unit is joules. That's the most basic problem I can give you. If I give you a mass and a height, you already know G. The only thing you can find from those is energy. Now, sometimes, as always, I can make this a little bit trickier by involving algebra. And so what if maybe I give you an energy and then ask you to find either height or mass? And so we'll see how that works here. So here's an example where I do just that, where I ask you to find either height or mass if I give you energy. And so all you're doing is using algebra to kind of work it backwards, where instead of giving you the starting information and asking you for energy, I started you with energy and asked you to find the starting information. And so all I have to do is plug these numbers where they go, replace their letters, and then use a little bit of algebra to solve. So G is still 9.8, and it basically always is. 80J, you have to look at that unit and figure out what it is. J stands for joules, and our unit for energy is joules, so we plug this in where energy goes. And then last but not least, 15 kilograms. Kilograms is a mass. And so we need to replace all of our letters that we know now with the numbers that we are told that stand for them. So I've got 80 instead of U equals 15 instead of M times 9.8 times H. Now there's kind of two ways to go at this point. You can move over the 15 by dividing by 15 and then divide by 9.82. That's one way to solve it. I think more people, though, will combine the like terms first and then divide by them. So I want to kind of resolve this 15 9.8 deal first. So I'm going to take 15 times 9.8, do that first, and I get 147 times H when I put that into my calculator. Equals 80. Now I can move it over, divided by 147, divided by 147, and so I end up with 0.54 with some other numbers that get rounded off equals H. And what do we measure our height in? What's H measured in? Meters. So it's a little bit harder because we have to use algebra, but not that much harder. Let me do one more for you here. Same deal. I gave you energy and a height, and now I'm asking you to find mass. So G is still 9.8. That one still goes there. 70 joules, J is energy, so that goes here. And then 3.5 meters. And again, I know it's confusing to see this M and see that M and think, oh, that's where it goes. No. M is the unit for height, and it's also the variable for mass. So don't just stick it where it goes. It's 3.5 meters, which measures height, H. And so when I set this up with my numbers, I'm going to have 70 equals M times 9.8 times 3.5. And now I just need to solve for M using algebra. And so I start by taking my 9.8 and my 3.5 and I combine those first. And I get 34.3. And then to get M by itself, I divide both sides by 34.3. And so I end up with 2.04 equals M. I just need a unit, and that unit is kilograms. And that's my answer. And so if I give you a mass and a height, you can find the energy. If I give you an energy and a height, you can find the mass. And if I give you an energy and a mass, you can find the height. Just a little bit of algebra in this equation go a long way. As always, this is Mr. Stewart. Keep learning, no matter what.